Welcome back, class. Thank you for joining me for our final notes to this first piece of chapter 7. We're already done after only 5 lessons. Now, today we're going to take yesterday's material, but just a little bit further. Okay, we're going to take it to the next step. So yesterday we talked about compounding interest. So the idea that you can compound annually. However, you'll make more money if you compound semi-annually because you're making interest on your interest. Same thing if you bump it up. If you compound monthly, if you compound weekly, daily, the more you compound, the more money you end up making because you are making money on each installment of the interest. Now, what if we construct an idea called compounding continuously? What if your money is always compounding? Then what's going to happen? Well, obviously this produces some problems because compounding continuously implies an infinite n. Okay, if you're always compounding, you compound an infinite number of times in a year. So n would basically be infinity. Now, you also know we can't really do much when dealing with infinity. You can't do actual calculations that way. So we had to find a clever way around that. Okay? So what we ended up doing is we constructed an idea, okay? We took that equation. So notice this equation should look familiar to you. That is our compounding interest equation. And we took it where x is going to infinity. Now this is called a limit. This is something you're not going to have to be able to do in Algebra 2. This is more of a pre-calc and calc concept. However, just do realize that when x approaches infinity in that case, it actually is approaching a value. It's honing in on a particular number. And what we did is we called that number the number e. Okay? Now the number e does actually have a value to it. All right? On the calculator, if you look, the number e is right on the division symbol. So if you do second, then the division symbol to get e, and press enter, it'll tell you a value. 2.717, blah, 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 blah. Just keeps going on. Think of e like pi. It is a constant. It is a number that is always the same, but it is also irrational. It's infinite. You'll never be able to represent it with decimals. But that's what this, not pi, that's what this e is, okay? It is the calculation of that limit, and we can use it for continuously compounding interest. So let's look at what that does to our equation. So now we've actually taken out a ton of that complicated mess in the equation. If you're compounding continuously, all you have to remember is PERT, all right? So you still have your principal, so that P is still the money you're putting into the bank. But now times e to the power of the interest rate times the time in years. Now again, with a stipulation, for the interest rate, we're always looking for a decimal, never, ever, 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 ever use a percent. Okay, still holds true in this case. But it actually simplified our equation quite a bit to do this. All right, now, there's a stipulation. When you're typing this into the calculator, you will still always want those in parentheses as well for it to calculate correctly. If you remember those parentheses, you can just type everything in one shot and boom, it'll pop out an answer for you. So let's take a look at our first example. So suppose you won a contest at the start of the 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. So there's that magical vocabulary, compounded continuously. That's telling us to use this particular equation. How much will you have in the account when you enter high school 4 years later? After you graduate high school 8 years later. All right. So let's begin by picking out some of that information, all right? So we're starting with $3,000. We have a rate of 5%, but again, we need to change that to 0.05. Never ever leave it as a percent. And in our first case, the t that we're looking for, we want to know about in 4 years. So let's plug all that in. 3,000 times e then in parentheses, point, oh, and I go and I write it wrong. I apologize. 0.05 times 4. That is literally all you have to do in this equation, and you will get it right. So let's type it in. 3,000 times e to the 0.05 times 4. And according to this calculation, you would have $3,664.21. And again, this is a perfect opportunity. You should have your calculator in front of you. Make sure you're getting that same calculation. Make sure you were doing this right, because if you're not, you need to ask me. Now, there was another question in here. It wanted to know about in 4 years. So after you enter high school, then it wants to know, what about 8 years? When you leave high school, how much money would you have? Well, you're starting with that same amount. That rate is going to be the same, 0.05. This time, though, we're talking about a greater t. We're talking about a t of 8 years. And that's what I'm going to be plugging into my equation. So 3,000 times e, then in parentheses, 0.05 times 8. Let's see what we get. And after 8 years, you would have $4,475.47. So again, I honestly believe this is probably the easiest of the equations that you have to know for this chapter. All right? It's just knowing when to use each of these. Now, speaking of that beautiful topic of knowing when to use each equation, if you flip the page, I've created a wonderful table for you. Okay, this is a little chart to help you keep straight what to do when. All right, there are 4 equations that you need to know for this chapter. All right, and yes, you do have to have them memorized. Now, there are indicators of when to use each one, and those indicators are going to be the vocabulary in the problem. So what I've done is I've listed the type of the equation, what each equation actually is, and then what vocabulary to look for. Now, there are some other words you could see, and I'm sure you guys can figure that out, but this is just in general the types of things you would be looking for, okay? Because on the test coming up, you're not going to be told, write a growth equation, write a decay equation. You have to pick out that vocabulary, and you have to figure out what to use when, all right? And this table will help you do that. It's kind of a one-stop shop for all these equations that you're going to have to know. So let's take a little bit of time to go back and reflect on some of these other types of equations we've been doing. So our first example, a culture of bacteria starts with 30 cells and grows at a rate of 16% every hour. How many bacteria will there be after 7 hours? All right, well, the word that sticks out to me is grows, okay? We're talking about a growing population. And that seems very familiar to our growth equation. All right? So once I picked out that we have a growth equation, and again, I can tell by the vocabulary grow, let's start looking for all of those pieces. So my A, my initial amount, well, I'm starting with 30 cells. How about my R, the rate? Well, my R is 16%. But I'm going to have to move that decimal place over twice because I need a decimal, not a percent. And then 7 hours is going to be our time. All right, so we're going to have 30 times 1 plus R, 1 plus 0.16. So we're going to have 1.16 to the 7th power. All right, and let's calculate what that would be. 30 times 1.16 to the 7 power. We're getting approximately 85 cells. Notice I rounded to a whole number. Why did I round to a whole number? Well, we're talking about a living thing. We're not going to have a part of a cell. You need to have either a whole cell or none. All right? We're not going to deal with decimals of living things. All right. The Smith family is saving up for family vacation. They want to take in 5 years. They put $1,200 in the bank that has an interest rate of 8.8% compounded monthly. How much money will they have by the time they want to take their trip? All right, so the key word here for me, compounded monthly. We're talking about compounding and it gives a specific amount. So that's going to be our compounding interest equation. All right, it's going to be the one right here. Do know which interest equation to use, all right? PERT versus the big one. So let's start picking out all that information that we need because this one takes a lot of information, if you recall. So the first thing we need to know the initial amount, the principal they gave the bank, that's going to be $1,200. We need to know the rate. Well, here, the rate is 8.8%, but again, we need to move that decimal place twice. So we get 0.088. Compounded monthly. Monthly, well, there are 12 months in a year, so that means N is going to be 12. And then how long? The T, where they're going to take their trip in 5 years. So we're going to calculate how much money will there be in 5 years. And now all we have to do, plug all of it in. So 1,200 times 1 plus that rate over N times N times T. All right. So again, remember how to write all of that out. And now if you use those parentheses properly, just as I have written them, remember you can type everything in at once then. And the answer you should be getting, $1,860.26. So please, please, please make sure that that is the answer that you're getting. Don't just write it down and take my word for it. Make sure you can do the calculation. So that is all for today and actually for the first half of this chapter. So as soon as you're done writing all of this down, please, please just make sure you have it written down, I guess, and then come back ready to do our practice work.